Welcome to SPSS PSY 3840, and I'm Professor Coolidge. Let's go to assignments. And we are up to Unit 4, which is the standard scores and the z-distribution. And we are going to learn all about standardizing raw scores and turn them into z-scores, and then turn these z-scores into t-scores. And so our goals here will transform raw scores into these standardized z-scores. We'll transform z-scores into t-scores, and I'll show you how to use the syntax editor. And so let's open up our data set. We're going to use the schizoid Asperger controls.sav data set, and let's open up our data set. And here's our data set. And so here's a good example of why we need a z-score or a t-score. This is a raw score. It's a sum of 45 items. And we can see a 66. We can tell relative to that. Here's one nearly double that, or just over double that, 66, and this is 133. So it might be a high score. But by a raw score, 7449, we can't tell whether these are high scores or low scores. And that's the value of a standardized score. So the first thing we'll want to do is convert this raw score, the Total Autistic Symptom Survey across 45 items, into a z-score. So we'll go up here to Analyze, we'll go to Descriptives, and we'll go now down to Descriptive Statistics. And it's already kicked over, which it shouldn't have, the Total Autistic Symptom Survey. So let's go back and isolate it here, identify it, kick it back over into the variables that we're interested in. And down here, this would be unchecked also, we'll see Save Standardized Values as Variables. So we're going to ask it to do that, which is not the default. And we'll click OK. Our output, this is in our output, it needs to get the mean and the standard deviation. Here we've identified, again, probably a clinker, because if it's the sum of 45 items, that means this person didn't answer 45 items or 15 items of our 45, which is identifying a very low score, which we may wish to eliminate as we continue. And but here what we'll do is we'll go into Windows and go back into our data, and we can see it has created our z-score. Now z-scores are typically reported only to 2 decimal places. So this is 5 decimal places, which is way too much. So we'll go into Variable View. Here's our new z-score. Notice I put it at the end of the data set. 5 decimal places, the standard is 2. And it'll actually look at the 3rd decimal place to round to 2. 11 decimal places we will never need. I mean whole numbers. So we'll go to 3 here. Whoops, one too many. Okay. And now we'll go back to our data view. And now we can see it's much more reasonable. So now we can see for this raw score, 66, we can see the z-score is negative 0.48. And this means it's a half a standard deviation below the mean. This was nearly 7/10 of a standard deviation below the mean, because the mean's 1. Here's one almost exactly 1 standard deviation below the mean. So a 49 for an SAS TOTE score yields this 1.001 standard deviations below the mean. Notice also, now half of these z-scores will be negative generally and half will be positive. Here's one. Here's our highest z-score, 2.12. So this 149 converts into a z-score of 2.12, which is 2.12 standard deviations above the mean. But in psychology, more interpretable is a standard score called a capital T score, just to introduce some confusion. And a capital T score are typically whole numbers with a mean of 50 and a standard deviation of 10. Now I've already done this for this executive dysfunctions variable here. And so we can see this raw score on executive functions has already been converted to a capital T, and that's a 53. So that says this person's 3/10 of a standard deviation above the mean, having executive dysfunctions like being unable to make decisions on one's own. Here's a person very able to make decisions, no executive dysfunctions because they're 1.1 standard deviations below the mean. Here's somebody 2 standard deviations above the mean on executive dysfunction. So what we're going to learn how to do here today in this lesson is convert this z-score. And the way we'll do that with SPSS is we'll go into new, we'll go into syntax, and we'll actually write the syntax to convert that z-score. So that means we're going to have to use a standard compute command, compute, and we're going to say compute a TSAS tote score. How are we going to do that? We're going to take, the formula would be the mean, and so we need the new mean is a 50 plus, and that's the new mean of a capital T score, plus the standard deviation, so that's 10 of a T score, times the actual z-score. So that was Z-S-A-S-T-O-T, which was in our data set. We'll put that in parentheses. We'll put a period. We'll put execute down here. So let's go over that again. If we're going to compute this new value, and it's going to add it to our data set, a capital T score for SAS tote, then you have to use the new mean, 50, times the new standard deviation, 10, but multiply that new standard deviation times the old z-score, then add it. If this thing's negative, then it's going to actually be subtracted from 50 and execute. So we'll hit run. We hit all. It says it did it. So we'll look in our window and we'll see, go back to our data here. And we can see it converted our z-score into a capital T score. Remember, this is a half standard deviation below the mean because the z-score has a standard deviation of 1. So this is negative. So that means it's nearly half of a value of 1.50 below the mean. Look at our SAS capital T score. Mean of 50, standard deviation of 10. So we can immediately tell this person's below the average child's mean for executive dysfunctions, about a half standard deviation, and we can see that. Except that T-scores are generally reported to just a whole number. So we're going to go over here to variable view on our new generated T-score, and we're going to say we don't want any decimals. And this, we could go down all the way. It's going to be unusual, but it can happen to have a whole number, a width of 3. And so we'll go back now into data view, and now we've got a very interpretable, just like the T's here, very interpretable SAS T-score. So now we can see this person's half standard deviation below the mean. We can see this person's at the mean. We can see this person's 1.6 standard deviations above the mean. We can see this person's exactly 2 standard deviations above the mean, because their z-score is 1.96 standard deviations, nearly a 2. But with a rounding error, it becomes T-score 70. T-score 71, which was the highest person in our sample. And that's 2 standard deviations z-scores with a standard deviation of 1. And here with T-scores, when the standard deviation is 10 times the standard deviation of the z-score, we see it's a 71. So now we can easily identify with these popular capital T-scores whether a person on this raw score is above or below the mean and how far they are from the mean. And that's our lesson today for z-scores, converting them into T-scores.